Hi, welcome back. Let's talk about barometric pressure sensors in my new podcast about important use cases and applications. I hope you enjoy it. Brought to you by Dr. Block from All About Sensors.
Okay, so think about how much you use your phone for location, right? Finding, the nearest coffee shop, getting to a meeting.
All the time. Absolutely.
But what happens when, GPS just vanishes or gets really weak?
Yeah, like indoors or deep in a city.
Exactly. Or imagine eating 9/11, but you're inside some tall building.
Yeah.
Or a drone trying to navigate between skyscrapers.
Yeah.
GPS kind of hits a wall there.
It really does, especially for vertical accuracy, knowing how high you are.
Right.
And that's where these MEMS sensors come in, micro electromechanical systems.
MEMS. Okay.
Tiny things. We're talking accelerometers, gyroscopes, magnetometers, even barometric pressure sensors. They fill that gap.
So that's our deep dive today then. How these little MEMS things, they're not just backup, they actually enhance navigation.
Precisely. For some really critical stuff like emergency services finding you indoors.
Okay, that's huge.
And making drones fly super accurately, even making your watch battery last longer. It's kind of the invisible tech making things possible.
Let's start with that indoor thing. Enhanced 911. You mentioned GPS is bad with height.
Terribly bad, yeah. Especially indoors. It just can't reliably tell emergency services what floor you're on. The Z-axis accuracy, they call it.
Z-axis for height. Got it. And you need that fast if you call 911 from, say, a high-rise.
Exactly. And there's actually an FCC mandate for this. Wireless carriers need to provide that Z-axis location accurate to within 3 meters for most 911 calls.
3 meters. That's pretty specific. So how do MEMS help there?
That's where the barometric pressure sensor shines. It basically measures the weight of the air column above you.
Like air pressure.
Exactly. Air pressure changes very predictably with altitude. Go up, pressure drops.
Huh. But doesn't weather change the pressure too, like storms and stuff?
Ah, good point. It does. So the clever bit is using a reference network. Systems like NextNav have fixed stations on the ground measuring pressure in real time.
Okay, so they compare your phone's reading to a known local pressure.
You got it. That cancels out the weather effect and lets a tiny sensor like the Bosch BMP 390, it's tiny, like 2 millimeters square, get you down to maybe a 1/4 meter accuracy.
Wow, a 1/4 meter. That's way better than 3 meters. That could tell them the floor for sure.
Easily. Maybe even, which side of the floor in some cases. It's a game changer for indoor emergencies.
Okay, so that's indoors.
Mm-hmm.
What about up in the air? Drones. You mentioned drones. How do MEMS keep them stable?
Right. Drones need incredible stability and precision, yeah. Especially with wind or complex maneuvers.
For sure.
So there, it's a combo. You use an IMU, that's an inertial measurement unit.
IMU. That has the accelerometer and gyroscope.
Correct. Measures motion and rotation. Then you add the barometric pressure sensor for altitude, like we just talked about. And a magnetometer.
A compass, basically.
Exactly, a digital compass. And even tiny errors in these sensors, like a little drift in the accelerometer, can mess up the drone's orientation over time.
You need really good sensors.
You really do. High-performance ones, like Bosch has an IMU, the BMI 088. Very low noise, very stable, even if the drone's vibrating a lot. Tech borrowed from the automotive industry, actually.
Makes sense. Cars need good sensors, too.
And for height, something like their BMP 388 pressure sensor gives maybe 2/3 of a meter accuracy. Put it all together, IMU, pressure, magnetometer, and you get what's called 9 degrees of freedom sensing.
9 dova. So the drone knows exactly where it is, which way it's facing, how high it is, everything.
Everything it needs for precise control, yeah.
Okay, this ties back to GPS too, right? You said MEMS augment GPS. How does it work?
Well, think about those GPS weak spots again. City canyons, tunnels, even just walking under a bridge.
Signal drops out, yeah.
Right, so when the GPS signal gets weak or disappears, an algorithm called pedestrian dead reckoning, or PDR, can take over.
Pedestrian dead reckoning. Sounds nautical.
Yeah, it's a similar idea. It uses the data from the MEMS sensors, the accelerometer, the gyroscopes, the magnetometer to basically calculate your path, step by step, turn by turn.
So it's like tracking your movement internally, even without seeing satellites.
That's a good way to put it. It keeps a log of your motion. And the result is, when you combine PDR with GPS, the tracking is much smoother and more accurate than GPS alone, especially when you're going into or out of buildings.
Seamless tracking. Okay.
And there's another huge win here, power saving.
Ah, right. GPS drains the battery.
Big time. So now you have these things called smart sensor hubs, tiny chips. like the Bosch BHI 160BP that have the IMU and a little low-power processor right on board.
All in one package?
Yep, super small, perfect for wearables, and that little processor can run the PDR algorithm itself very efficiently.
So the main phone or watch processor doesn't have to.
Exactly, and the hub can be really smart about it when the MEMS sensors can handle the location tracking accurately enough using PDR.
It tells the GPS chip to take a nap.
Pretty much. It adaptively turns the GPS receiver on and off, duty cycling, they call it.
And that saves how much power?
It can be significant, up to maybe 80% reduction in the overall system power used for location compared to just leaving the GPS running all the time.
80%. That's huge for a smartwatch battery.
It really is. It's a major reason why wearables can track activity for days now, not just hours.
So wrapping this up then, these tiny, almost invisible MEMS sensors, they're doing some heavy lifting.
Absolutely. They bring precision or GPS struggles, reliability in tough spots, and amazing power efficiency, solving some really fundamental navigation problems.
It really makes you think, doesn't it?
Yeah.
This tech is just sort of everywhere but hidden.
Mm-hmm.
What happens next? I mean, how could this totally seamless power-sipping location capability change how we interact with everything, even in places we currently think are impossible to navigate?
That's the fascinating question, isn't it? The possibilities are, well, pretty vast.
Mm-hmm.
Thanks for watching. I hope you liked it or learned new things. Please also visit me on X, Instagram, or read my blog articles on WordPress. Bye.